students and welcome to our YouTube channel Eng.Med Models. So in the previous videos we have started the lesson number 11, that is pressure. Okay students, first of all, what is pressure? We have seen that pressure is, what is pressure? Pressure is defined as force per unit area. So this is pressure. Pressure is defined as the force per unit area. You just have to remember this, that what is pressure? Force per unit area. Just you have to remind this, and the question also can be asked that what is pressure, then you have to write force per unit area. Okay students, and then there was a formula that of P. Okay, so P is equal to F upon A. Sorry, capital A. So this was the formula of force upon area, means pressure is equal to force upon area, that is force per unit area. Just we have seen some of an activity also, that how can the pressure be filled. Let us also discuss that also. See here students, there was two cases. That in the first case, if there is here there is a lag, okay students, and in the case 1, here the sandals have smaller area, okay students, and force is applied, and here case number 1 and here case 2. Okay students, in the next case it was case number 2. In the case number 2, there was a big area. Okay students, in the case number 2, there was the area was big. Okay students, so what happens if we take the formula as P is equal to F upon A in the case number 1. So what will happen here? The area is small or big. The force is same in the both cases. Let me write here, force is same in both cases. Okay students, force is same in both cases. Here the area is small and here the area is big. Okay students, so what will happen is, here as the force is same, but here the area is less, means if the denominator is less, then we get the answer is big. Okay students, and here the area is big, that is P is equal to F upon A. Here what is big? Here the area is big. If the denominator is big, so the answer that we get is less. So we get the pressure less. And we have also solved some of the numericals of it. Okay students, and now we will go further. Pressure in fluids. We have also seen that pressure in fluids, that as you already know, liquid and gases are collectively called fluid. An object present or immersed in a fluid experience pressure in all directions. We have seen one activity of balloon and atmospheric pressure. We have also seen this activity. What is atmospheric pressure? We have just learned that the air and all gases exert pressure. If air exert pressure, what about the sea of air that we are living in? Does our atmosphere exert pressure on us? Let us find out. There is an activity we have seen that, and another activity, the pressure of atmospheric pressure. Okay, students, that we have also seen. And lastly, we have seen was the atmospheric pressure. What is atmospheric pressure? Atmospheric pressure is defined as the pressure exerted on an object by the weight of the air above it. So, what is atmospheric pressure? Atmospheric pressure is defined as the pressure exerted on an object by the weight of the air above it. Okay, students? Here, now we go to the pressure in liquids that we have seen. Now we will go to the pressure in liquids. So, first of all, what is pressure in liquid? First, we have seen in the fluid. Now we will see the pressure in liquid. Can you imagine? First of all, read the pressure in liquids. Okay, students? Up till then, I will rub the board. See the introduction part of the pressure in liquid. So, here pressure in liquid. In this, we will see how pressure is applied pressure in liquid. Okay, students, let us see that. Here there is an activity about pressure in liquid. Let us first of all see that. See here, students, activity to show that water exerts a pressure on the container that holds it and on all objects immersed in it. Okay, students, let us see that material needed. We just need a rubber ball, water tap, bucket of water, and an empty plastic water bottle. Okay, students. So, first method: fill water in the rubber balloon by holding it below the tap. Okay, students. What do you see? The balloon expands just like it did when you blew air into it. We have to see that the balloon expands or not. In the first case, we just filling the as it is blast. The balloon was blast. Next, remove the water in the balloon and blow it up with the air. Okay, students, try to push into a bucket full of water. What do you feel? You will feel the air filled balloon being pushed back by the water. Means if the balloon is filled with air and if you push that in the full of bucket of the water, then we can feel the pressure of water that is keeping the balloon upside. Okay, students? Now, if you let it go, it will be pushed right back to the surface of the water in the bucket. If you push the balloon deeper, you will find that it is pushed back to the surface again. As a second experiment, close the cap of the water bottle and push the water bottle into the water in the bucket. You will experience the same result. So what you have to do, first of all, we have to do the first of all, you have to fill the balloon with water and then put it in the full of bucket. You can see that the balloon can go inside. But if then after remove the water from the balloon and then fill the air and put it into the full water full of bucket full of water and do pressure on it, you will see that the water is giving pressure back to the balloon to go on the surface. You can experience that. And another experiment was the bottle without any of the water bottle without water. Just keep the cap close and just push the bottle. You will feel the same experience. Okay, students, discussion and conclusion. Water and other liquids exert pressure on the container that holds them. This is why the balloon expands when water was filled in it. Water also exerts a pressure on all objects immersed in them. The pressure at point increases as we go down from the liquid substance. Okay, students, so this was the activity. Now here, see here, pressure in liquids. We have seen the dams. In that there is one wall which protects all the water, means the wall don't get the pressure of liquid or water. Okay, so let us discuss that. Walls of dam are made thicker at the bottom, so they can withstand great pressure at the great depth under water. Means we can see that the walls of the dam is bigger in the size, means they have the great pressure of water, so they have to withstand the water. Okay, students, deep sea divers have to wear special suits to protect themselves from the great pressure of the water at great depth. We have seen also the scuba divers which go into the water, and there is some special suit for them for going deeper, so that they don't get the water pressure. Okay, students, and next, here is an activity to understand that water exerts pressure in all directions. Now there is an activity that water exerts pressure in the all direction. Let us see that. And to understand that water exerts pressure in all directions, material needed: about 30 centimeter plastic or rubber pipe used to water plants, a rubber balloon, and a water tap. See here method. Attach the rubber balloon to one of the end of the pipe and fill water from the tap through the other end. Fill water till the balloon expands a liter. Hold the free end at the tube of a liter higher than the end with the water filled. Balloon hold the end with the balloon at a different angle, so that the balloon faces up, down, horizontal, and other angles you can think of. Keep an eye on the balloon all time. Observation: you will find that no matter what angle you hold the balloon, it remains inflated due to the pressure of the water inside. Conclusion: this shows that water exerts pressure in all directions. Okay, students, water exerts pressure in all directions. There was an activity of 8. Okay, students. Now next, how the pressure is measured. That here there is a device which is known as nanometer. Okay, students, this is a device which is used to measure the pressure. Okay, students, let us discuss about the manometer. Open tube manometer. Open tube manometer. So what is open tube manometer? Let us discuss that. An open tube manometer is one of the simplest devices used to measure pressure. So what is the first point of the open nanotube meter? It is used to measure pressure Okay, this device is used to measure pressure. Okay, so this was the first point, and it is called a pressure gauge. It is also known as pressure gauge. It consists of a U-shaped glass tube filled partially with water. There, see here, I am making this figure over here, small figure. You can see that here there is a see here, students. See here, students. We are just drawing a figure of open tube manometer. I can't draw the perfect figure of it. Okay, students, just you can imagine that it is a manometer tube. There is a U-type tube. Here there is a scale. There are some of the measures over here. So this is the manometer, open tube manometer. Okay, students. See here, it is called a pressure gauge. It contains a U-shaped gauge, U-shaped glass tube filled partially with water. There is a scale. Here is a scale. Okay, students, in between the two arms of the U-shape. In between the two arms of the U-shaped tube. Okay, students. To measure the level of the water, each arm, one arm of the U-tube is open and the another is close to the rubber. Normally the level of the liquid in the two arms of the U-tube is the same. Okay, students, when the pressure is to be determined at a point, the rubber tube is held at the point, and from the difference in the heights of the liquid at the two arms of the U-tube, the pressure can be calculated. The scale of on the manometer could also be marked so as to read the pressure directly. Okay, students, this is the manometer which is used to measure pressure. So here there is a scale and here there is a U-shaped tube, and one end is closed and one end is open, and here there is filled with water. Okay, students. So when if we want to see the pressure, then this it is filled, and we can also measure from the scale that how much pressure is there. Okay, students, this is the manometer tube. Now next, here are some of the applications of the pressure. Let us discuss that. Many useful devices and equipments have been manufactured by applying the concept of the pressure and what it depends on. Here are the few examples along with the principle behind the application. Pressure can be increased by reducing the area over which the force acts. Okay, students, now I am writing the main points also of it, the applications of pressure. Here are some of the applications of pressure. I am writing here the main things that which are the applications of the pressure. Let us see that applications Applications of pressure. See here, first of all, we will write this. Pressure can increase. Pressure can be increased by reducing the area over which the force acts. Okay, students, so we have learned it further that as the area is less, the pressure value increases. See here, pressure can be increased by reducing the area over which the force acts. Means if we reduce the area from which the pressure is to be applied, then the pressure increases. Okay, students, let us see some of the examples of it. Here are some of the examples of it, that are needles, pins and syringes are given a very sharp point, so that with little force they can be passed through cloth, paper, skin, etc. as they need maybe. Okay, students, knives and blades are given sharp edge, so that they can be used to cut things without much effort. Okay, students, here the next one is the next point, that is pressure can reduce. Pressure can be reduced pressure can be reduced pressure can be reduced by increasing the area over which a force acts. Okay, students, if we increase the area over which a force is to be acted, pressure can be reduced by increasing the area over which a force is to be acted. Means if we have to increase the pressure, what we have to do? We have to decrease the area, and if we have to reduce the pressure, then we have to increase the area. Here are some of the examples of it. Let us see that. Have you noticed that the tires of different vehicles have different width? Bicycle tires are very slim, whereas big buses and trucks have very wide tires, sometimes even 2 or 4 tires together instead of one. To understand this, we have to remember that pressure is a force per unit area. Biggest vehicle like buses and trucks have bigger weight, that is, they extract a great force on the road as compared to the lightweight like bicycles. To compensate for the large force, the wheels of buses and trucks are made wide to increase the surface area, so that the pressure exert on the road is reduced. So the big trucks and buses which are heavily loaded, so it don't harms to the road, so the surface area of the tire is increased, so that it not harms to the road. Okay, students, now the another one we will see in our next video. So now please write down your today's homework. Okay, students. Another one we will see in our next video. Up till then, please write down your homework. So your today's homework is today's homework question number 1. Define atmospheric pressure, This is your question number 1. And question number 2, that is explain why the walls of dams are made thicker at the base. So these are the two questions that you have to write down in your homework. Okay, students. First question, define atmospheric pressure, and question 2, explain why the walls of the dams are made thicker at the base. These two questions you have to write in your homework. Up till then, stay safe, stay home. Okay, bye students.